Hello everyone, welcome back to my channel Strictly Logical. Today I have come up with another video to explain you exponents and powers. In this video I am going to explain you the basic concept of exponent and powers. We will see what are the different uses of exponents, what is the meaning of a square of a number. You will see how to write the product of powers of prime numbers, and then at the end we will see the powers with negative and positive exponents. So let's begin this video. As you can see that this is a moon. Do you know the mass of the moon? So let me tell you, the mass of the moon is this much, 7350000 kg. Can you read this number? This massive natural number is not easy to read or even recognize all these long digits accurately. So in order to give a precise evaluation of the mass of the moon, we can use exponents. So let's see how can I write the same number using the exponent. The mass of the moon is this much, which can be written in the exponent form like this, 7.35 into 10 to the power 22 kg. So now let's study exponents and powers in detail. First of all, how we read the given numbers. Here it's written like that, 10 and 2. 2 is written in the superscript. It can be read as 10 raised to the power 2, or in simple words you can read it as 10 square also. Second number is this. This can be read as 2 raised to the power 5, or in simple word 2 to the power 5. Now what does that mean? So before going into detail in this topic, let's understand the basic terms which we're gonna use in this topic. So base is a number which is to be multiplied by itself according to the exponent. The number which is written like this, that is known as base, and the number which is written in the superscript, that is known as exponent. Next, exponent or index is a number which represents the number of times a base is to be multiplied by itself. Dear friends, please pay attention here. This can be read as 10 to the power 9. This means that the base 10 needs to be multiplied by itself how many times? 9 times. Exponent suggests the number of times a base needs to be multiplied by itself. It does not mean that 10 is multiplied to 9. Now let's see how to write these large numbers in exponential form. Let's consider a few examples to understand the concept in a better manner. The first example is 10 to the power 2, or you can simply read it as 10 square. This means 10 is multiplied by itself 2 times, 10 into 10. In this case, 10 is our base and 2 is our exponent. Second example, 2 to the power 5. This means that 2 is multiplied by itself 5 times. In this case, 2 is our base and 5 is the exponent. So we can say that exponent represents the power. Now we have seen that 10 is base and 2 is exponent here. This is the positive power. In generalized form, the exponential form can be written like that, a to the power m, where a and m are some variable. A is base and m is exponent. In other words, a to the power m means multiply a by itself m times. Now you must be wondering how to find the value of power. So let's understand this by taking one example. Suppose we have to find out the value of 6 to the power 4. As I told you, it means that 6 is multiplied by itself 4 times. Therefore, the value of 6 to the power 4 is 1296. Now let's see what is the square of a number. Square of a number means that number is raised to the power 2. For example, square of 4 means 4 to the power 2. That means 4 needs to be multiplied to itself 2 times. That is 4 into 4, 16. Square of 13 means 13 into 13. That is equals to 169. Let's see how to write product of powers of prime factors. Let's try to understand this with one example. Suppose we need to write 432 as product of powers of prime factors. We will do the prime factorization of 432 and we will get 4 2's and 3 3's. That's why we will write it as 2 to the power 4, 3 to the power 3 in the simplest form. Thus 432 can be written as 2 to the power 4 into 3 to the power 3. Let's consider a few more examples to understand the concept of exponents and powers in a better manner. For example, here I have taken base as 3 and power as 1. It means that 3 needs to multiply to itself 1 time. So that will be equivalent to 3 only. Suppose let's increase the power to 2. It means 3 square. 3 needs to multiply to itself 2 times. That will be equivalent to 9. Now I have increased increase the exponent to 5, which is equals to 243. Now I have increased the power to 24. It means 3 needs to be multiplied to itself 24 times. So friends, as you can see that this is not easy to read or evaluate, but exponent and powers help in writing the large numbers in a shorter form which can be read, understand and compare easily. Instead of writing 3 24 times, we can simply write it as 3 to the power 24 and we will get the value as this much. So friends, now I have an interesting fact that for any non-zero number x to the power 0 will always be equals to 1. The reason behind this is because any number to the 0 power is just the product of no numbers at all, which is the multiplicative identity, that is 1. I have already uploaded a video on the properties or the laws of the numbers where you can find the brief description of multiplicative identity. The link to that video is given in the description box. You can check that out later. And for any non-zero number x to the power 1 is the number itself, which means that the given number is multiplied to itself one time. Now let's see some examples with positive exponents. We know that 10 square is equals to 10 into 10, which is equals to 100. Similarly, 10 to the power 0 means 1, as I told you earlier also. 10 to the power 1 is 10, 10 to the power 2 is 100, 10 to the power 3 is 1000 and 10 to the power 4 is 10,000. Next is negative exponent. Negative power is almost similar to the positive power of the exponent. The only change is that the value of the expression is the reciprocal of the value that is obtained in the positive case. Powers with negative exponent is also known as negative integral exponent. So whenever we have negative exponents, we have to think of the opposite. Opposite of positive is negative and the opposite of multiplication is division. So in case of negative exponent, instead of multiplying the numbers to n number times, we divide the number each time, which is same as the multiplying by 1 by of the number. That means the reciprocal of that number. For example, 8 to the power minus 1 is equals to 1 upon 8, which is equals to 0.125. This 5 to the power minus 3 can also be written like that, 1 upon and then multiply 5 3 times. You will get 1 upon 5 to the power 3. But the important point to remember is that we have written it in reciprocal form. And this 1 upon 5 to the power cube can be written as 1 upon 125, which is equals to 0.008. So in generalized form, what we need to remember is in case of negative exponent, we just need to flip the positive exponent. For example, a to the power minus n is equals to 1 upon a to the power n. Here the power is negative and if we do the reciprocal of that number, that power will become positive. Another method to solve the negative exponent is calculate the positive exponent first, that is a to the power n, and then take the reciprocal of it, that is 1 upon a to the power n. Let's consider a few examples to understand it. 4 to the power minus 2 can be written as 1 upon 4 to the power 2. Now please notice that here the power was negative, but if we have written the reciprocal of the positive exponent, it will become 1 upon 4 square, which is equals to 1 upon 16, that is equals to 0.0625. Second example is 10 to the power minus 3. Write the reciprocal of the positive exponent. It will be 1 upon 10 to the power 3, which is equals to 1 upon 1000, and in decimal it can be written as 0.001. The last example in this case is minus 2 to the power minus 3. This time base and exponent both are negative. First of all, you have to make the power positive by taking the reciprocal of the number. This can be written as 1 upon minus 2 to the power 3, which means 1 by minus 2 into 1 by minus 2 into 1 by minus 2, which is equals to 1 by minus 8. That is equivalent to minus 0.125. Here one thing which is very important to note down is we have to be very careful while inserting the base and power in the parenthesis. And why is it important? I'll explain it with some examples later in this video. Before that, let me tell you this interesting fact that whenever the exponent is decreased by 1, the value becomes 1/10 of the previous value. For example, 10 to the power 2 is 10 into 10, which is equals to 100. While if we decrease the power by 1, it becomes 10 to the power 1 now, which is equals to 1/10 of the previous value. The previous value was 100. 100 by 10 is equals to 10. Now again decrease the power by 1, you will get 10 to the power 0, which is equals to 1. The previous value was 10. 10 divided by 10 is 1. Again decrease the power by 1, you will get 10 to the power minus 1, which is equals to 1 by 10, that is equals to 0.1, and this is the 1 by 10th of the previous value. Our previous value was 1. Now look at the representation of the power powers with negative exponent. In case of positive exponent, we write the generalized form as a to the power m, while in case of negative exponent, we write the generalized form as a to the power minus m, where a is the base and minus m is the negative exponent. We can say that a to the power minus m is the multiplicative inverse of a to the power m. The term multiplicative inverse I have explained in the same video in which I have explained the properties of the numbers. The link to that video is given in the description box. We can also write it as a to the power minus m equals to 1 upon a to the power m, where m is a positive integer. Now comes the most important section of this video. These few tricky exponential expressions come almost in every exam. Let's consider first example as minus 1 to the power 1000. Second example is 1 to the power 250. You can see that the exponents are very large numbers. So let me tell you one shortcut to solve all these questions. To solve first question, minus 1 to the power 1000, its answer will always be equals to 1. And why so? Because a negative number taken to an even power gives a positive result because the pair of negatives cancel out. Here 1 to the power 250, 1 multiplied by itself n number of times will always gives you 1 as the final answer. Again, next third example is minus 1 to the power 121. You can notice that our base is minus 1. Base is negative this time, but the power is an odd number, which is 121. Its final answer will always be equals to minus 1. And why so? Because a negative number taken to an odd power gives a negative result, because after cancelling there will be one negative sign left over. So whenever you have negative 1 and in its power, if you have a very large even number or odd number, you can write the respective result. In case of minus 1 to the power even number, 1 will be your answer, and if the power is an odd number, you will get minus 1 at the final answer. Next example, 10,000 to the power 0. We have seen that any number to the power 0 will always be equals to 1. So friends, this was all about exponents and powers. In my next video, I'll teach you about the laws of exponents. So if you are new to my channel, please subscribe to it to get the important updates. Thank you for watching.